As we set the stage for the transformation of Titan, we need to understand the monumental task that is terraforming. It's more than just turning a lifeless landscape into something habitable. It's about completely rewriting the natural laws of a celestial body to suit our needs. But how do we even begin to alter a world like Titan? At first glance, Titan seems almost impossible to tame. With surface temperatures colder than anywhere on Earth and a thick atmosphere mostly made of nitrogen, we face challenges that stretch the limits of our current technology. But this is where the concept of terraforming becomes revolutionary. It's not just about surviving in hostile environments, it's about manipulating those environments on a scale that seems straight out of science fiction. Let's take a moment to look at the concept itself. Terraforming, as an idea, isn't new. The term was first coined in the mid-20th century by science fiction writers. But even as we approach the 22nd century, it remained an unattainable dream until now. In the year 2150, we finally have the technological tools, the scientific understanding, and the drive to push the boundaries of what's possible. To terraform a planet, or in this case, a moon, means altering its atmosphere, temperature, surface topography, and ecology to make it Earth-like. But this isn't just about making Titan look like Earth. We want it to support life as we know it, to make it a new home for humanity. The core of the process lies in three key areas: atmospheric engineering, temperature control, and the introduction of life. Each one poses its own set of nearly impossible challenges. How do we warm up a world that's colder than the poles of our planet? How do we create an atmosphere that can sustain human life? And perhaps the most daunting, how do we nurture life on a world where none has existed before? These questions may seem unanswerable now, but by breaking them down step by step, we'll see that the science behind terraforming Titan isn't magic. It's the product of centuries of human innovation and perseverance. And as we'll discover, some of the answers are already within our grasp. To start with, the first step in the terraforming process involves creating a breathable atmosphere. Titan's thick atmosphere is rich in nitrogen, which is actually beneficial. It's the same primary component of Earth's air. However, the major problem is the methane. Methane in Titan's atmosphere forms a thick haze that blocks sunlight and keeps the surface icy cold. The question we face is, how do we remove this methane and what do we replace it with? Scientists in 2150 have developed sophisticated chemical and mechanical methods to begin removing methane from the air. One approach involves massive orbital platforms equipped with advanced filters capable of scrubbing methane from the atmosphere. These platforms are designed to work in tandem with vast ground-based facilities which release carefully calculated amounts of greenhouse gases. Yes, the very same gases we once feared on Earth. But here, we need them to warm Titan's frigid surface. This brings us to the second challenge, raising the temperature. Titan's distance from the sun and its thick haze make it incredibly cold, with average temperatures dipping below -180 degrees Celsius. To warm Titan, we'll employ two major strategies: orbital mirrors and controlled nuclear fusion. Orbital mirrors, reflective structures hundreds of kilometers wide, will be positioned around Titan to redirect sunlight toward its surface. This will help to slowly melt the frozen methane lakes and start raising the temperature. In addition, controlled nuclear fusion reactors will provide a direct, constant source of heat, stationed strategically across the moon to warm up critical areas. Yet this only scratches the surface of what it will take to reshape a world like Titan. In the next phase, we'll explore how life, at its most microscopic level, will be introduced to help kickstart an entirely new ecosystem. Because transforming a world isn't just about temperature and atmosphere, it's about building a foundation for life, starting with the smallest forms. As we move further into the concept of terraforming, it's crucial to understand exactly what we're up against on Titan. While the moon holds promise, its environment presents a set of challenges so extreme that one might wonder if attempting to terraform it is even possible. Let's start with the temperature. We touched on this earlier, but to truly grasp how hostile Titan is, picture this. The surface is colder than the coldest places on Earth, with temperatures averaging around -180 degrees Celsius. At that level of cold, basic human activity becomes impossible. Metal becomes brittle, fuels freeze, and any exposed skin would instantly freeze solid. To warm an entire moon, we need not just the orbital mirrors and fusion reactors we discussed, but a consistent long-term plan that battles the frigid cold over centuries. But it's not just the temperature. Titan's surface is covered with lakes and seas, not of water, but of liquid methane and ethane. Imagine standing on the shore of one of these lakes. It would look like a toxic, oily sea, reflecting the dim light of the distant sun, surrounded by thick, swirling clouds. This liquid methane is not only hazardous to human life but poses a risk of explosive reactions if introduced to too much heat too quickly. So while we need to warm Titan, we must do so delicately, avoiding any rapid changes that could destabilize its surface or atmosphere. Another significant challenge is Titan's gravity, or rather, the lack of it. Titan's gravity is only about 14% that of Earth's, meaning that everything from human activity to infrastructure development will need to account for this. Imagine trying to build skyscrapers or even simple structures without the normal gravitational pull we're used to. Things behave differently. Materials won't settle the same way, and even movement for humans could feel disorienting, with each step more like a slow leap than a walk. Yet another issue is Titan's thick atmosphere, which, while helpful for creating a shield against radiation, presents its own set of problems. With a surface pressure 50% higher than Earth's, it's almost like being deep underwater without the actual liquid. The atmosphere is so thick that sunlight struggles to break through, meaning that even after we begin to warm Titan, its surface will remain dim and shadowy. And while this thick atmosphere contains nitrogen, which we need, it also holds methane and hydrogen, gases that could prove hazardous as we begin to modify the environment. The chemical composition of Titan's surface also poses a challenge. Most of the moon's ground is covered in icy rocks made of water ice mixed with other hydrocarbons. This frozen mixture forms the bedrock of Titan's landscape, but it's incredibly difficult to work with. Think of trying to mine or build on ground that's not made of traditional rock but of frozen, slippery, flammable compounds. Any kind of construction or infrastructure development must take into account these hazardous conditions. Even the simple act of introducing water, something so basic to life on Earth, becomes complex on Titan. While there is plenty of frozen water on the moon, melting it and maintaining it in liquid form requires a delicate balance of pressure, temperature, and atmosphere control. Too much heat and the water will evaporate quickly. Too little and it refreezes, rendering it unusable for any life form we hope to introduce. Another critical consideration is the radiation Titan receives from space. Although Titan's thick atmosphere protects it from a lot of cosmic rays and solar radiation, it's still exposed to the powerful magnetosphere of Saturn. This magnetosphere traps particles from the sun and bombards Titan with radiation that, while less intense than what we'd find on other moons or planets, still poses a threat to long-term human settlement. We'll need to create artificial magnetic shields or underground habitats to protect future inhabitants from these dangers. Let's not forget about the challenge of time. Terraforming is not something that happens overnight, it's a centuries-long process. What we begin in 2150 will not come to fruition in our lifetimes. In fact, it may be hundreds of years before Titan becomes a fully habitable world. This raises complex questions about commitment. Who will oversee the project as generations pass? How do we ensure that future leaders, scientists, and settlers continue the work without abandoning it halfway through? All of these challenges, temperature, gravity, atmosphere, chemical composition, radiation, and time, make Titan one of the most difficult bodies in our solar system to terraform. Yet these obstacles also represent the pinnacle of human ambition. We've always been a species that thrives on overcoming the impossible, and Titan is no exception. By addressing these challenges head-on, we will lay the groundwork for what comes next, creating the conditions for life, one small step at a time. As we begin to address the monumental challenges of transforming Titan into a habitable world, it's essential to understand that this isn't a task that can be handled by one type of expert or even one organization. Terraforming Titan requires the collaboration of some of the most brilliant minds from across disciplines, working together on problems no single person could solve alone. So, who are the individuals and groups responsible for this unprecedented effort? Let's break it down. First, we have the planetary scientists, the people who study worlds like Titan in all their complexity. These scientists have spent decades mapping Titan's surface, analyzing its atmospheric composition, and understanding its geological history. Their knowledge forms the foundation upon which the entire project is built. They know every nook and cranny of Titan's surface, from its methane seas to its icy plains, and can predict how different sections of the moon will respond to the various phases of terraforming. Next, there are the atmospheric engineers. These specialists focus on one of the most difficult tasks in terraforming, altering Titan's thick nitrogen-methane atmosphere to something more breathable. Atmospheric engineers are responsible for designing and deploying massive orbital platforms and atmospheric scrubbers to remove methane while introducing gases that can sustain human life. Their work involves creating the precise balance of oxygen, nitrogen, and greenhouse gases needed to not only support life, but also ensure the planet warms enough to maintain liquid water. Working closely with them are the climate engineers, whose job is to manage the process of warming Titan. We've discussed the use of orbital mirrors and nuclear fusion reactors, but the actual execution requires a deep understanding of Titan's unique climate. These engineers must carefully calculate how much heat to introduce, where to introduce it, and how to distribute it evenly across the moon's surface without causing dangerous shifts in temperature. A misstep here could result in runaway warming or a catastrophic environmental collapse. Another key player in this process is the astrobiologists, scientists who specialize in the study of life in extreme environments. The first life forms to colonize Titan won't be humans but extremophiles, tiny organisms that can survive in conditions no Earth animal could tolerate. Astrobiologists are responsible for identifying which organisms can be introduced into Titan's harsh environment and determining how they can be used to help jumpstart the planet's ecosystem. These organisms will need to be genetically modified, and the astrobiologists are working with cutting-edge biotechnology to create the microbes that will thrive in Titan's methane-rich, low-temperature atmosphere. Then, there are the biotechnologists and genetic engineers. Their role is critical in modifying both microbial life and eventually, plants and animals that can survive on Titan. This involves tweaking DNA to adapt organisms to low gravity, low sunlight, and extreme temperatures. The biotechnologists aren't just trying to replicate Earth's ecosystem on Titan, but rather create a new engineered ecosystem tailored for the moon's unique conditions. The environmental architects are another crucial part of the team. Once the surface is warmed and some degree of atmosphere is created, the architects step in to design the first human habitats, biodomes capable of sustaining human life in the early stages of terraforming. These structures must protect settlers from any remaining methane, the extreme cold, and the low gravity. Additionally, these architects need to think about how future cities might grow as Titan becomes more hospitable over the centuries. Their work isn't just about shelter, but about creating entire infrastructures for future Titan societies, from energy production to water management and food cultivation. Speaking of energy, we have the fusion engineers. Titan's harsh environment means we need constant, reliable sources of energy that don't depend on solar power alone, especially given the dim sunlight that reaches the moon. Fusion engineers are tasked with building and maintaining the massive nuclear fusion reactors that will power the terraforming process, as well as the early colonies. They also work on smaller, portable reactors that will heat the first settlements and provide electricity for everything from life support to food production. Let's not forget the materials scientists and civil engineers. On Titan, building anything requires materials that can withstand extreme cold, low gravity, and potential chemical reactions with the methane-rich environment. Materials scientists develop new alloys and construction techniques tailored specifically to Titan, while civil engineers are tasked with designing infrastructure like roads, transportation networks, and communication systems that can function in such a unique environment. Then there's the psychologists and sociologists. While we often think of terraforming as a purely physical process, we can't ignore the human element. Psychologists study how people will adapt to living in an alien environment for long periods, potentially cut off from Earth. They develop training programs to help settlers deal with isolation, low gravity, and the psychological stresses of life on a partially terraformed world. Sociologists work on creating social structures and governance models that can support a growing human population on Titan, taking into account the challenges of living in a place that is still, for all intents and purposes, an alien world. Lastly, we have the mission coordinators and logistics experts. Their role is to oversee the entire terraforming effort, coordinating between the various scientific, engineering, and architectural teams. They manage the flow of materials, personnel, and information between Earth and Titan, ensuring that everything arrives on time and that every phase of the project proceeds according to schedule. Together, these diverse groups form the core of the terraforming effort. They bring together knowledge from biology, physics, engineering, psychology, and more, all aimed at solving one of the greatest challenges humanity has ever faced. But this is just the beginning. With the team in place, the next step is to move from theory to action, to begin the first phase of terraforming, and see if the vision of a habitable Titan can truly become reality. Alright, now that we've met the team and understand the massive scope of this project, it's time to dive into the first major phase of terraforming Titan, modifying its atmosphere. If we want to live on Titan, the very air around us has to change, and that's no small task. So, what's the first step? Well, Titan's atmosphere is thick, thicker than Earth's, and that actually works in our favor. The problem is that it's composed of nitrogen, methane, and other gases that aren't exactly breathable. But here's the thing, nitrogen is great. It's already 78% of the air we breathe on Earth. The issue is the methane. We need to remove that methane and replace it with oxygen if we're going to make Titan's air breathable for humans. But why is methane such a problem? For one, it's toxic. Breathing it would be deadly. But even beyond that, methane blocks sunlight and keeps Titan incredibly cold. So, if we want to warm Titan up and let sunlight through, the methane has to go. The question is, how? Well, the answer is a combination of orbital technology and ground-based solutions. First up, we have these incredible orbital mirrors. These are massive structures, kilometers wide, that orbit Titan and reflect sunlight onto its surface. Now, these mirrors serve two purposes. One is to start warming Titan up gradually, but the second, and arguably more important at this stage, is to break down methane molecules in the atmosphere. See, sunlight contains ultraviolet rays, and when you focus enough UV light on methane, it starts to break apart the molecules. This process, called photodissociation, is something we're already familiar with. On Earth, our atmosphere does the same thing to methane, albeit at a much slower pace. But with these orbital mirrors, we can speed up the process dramatically, breaking down Titan's methane far more quickly than would ever happen naturally. But here's the thing, just breaking down methane isn't enough. We also need to replace it with something breathable: oxygen. And this is where things get really interesting. On Earth, oxygen is produced naturally by plants and microbes. But on Titan, we can't just drop a bunch of trees and hope for the best. The environment is far too hostile for plants at this stage. So instead, we'll turn to one of the most exciting technologies of the 22nd century, artificial photosynthesis. This might sound like something out of science fiction, but we've already been working on it for decades. Artificial photosynthesis mimics the way plants convert sunlight into energy and oxygen, but it's much more efficient. We'll deploy massive arrays of artificial photosynthesis units, essentially giant machines that take in carbon dioxide, which is also present in Titan's atmosphere, and water vapor, and then use sunlight to produce oxygen. These units will be strategically placed across Titan's surface, particularly near the methane lakes, where they can work continuously to pump out oxygen. But of course, producing oxygen isn't the only thing we need to worry about. Titan's thick atmosphere means that air pressure is higher than on Earth. In fact, it's about 50% higher, which is like standing at the bottom of a shallow ocean. That might not sound too bad at first, but for long-term human habitation, this high pressure presents a challenge. We need to lower the pressure to something more manageable, but we can't just vent the atmosphere into space without causing all sorts of chaos. So, what do? This is where atmospheric scrubbers come in. These are ground-based stations designed to gradually siphon off excess gases and break them down or store them safely. The methane that's been broken down by UV light is captured by these scrubbers and either stored in underground reservoirs for potential future use, or broken down further into less harmful compounds. It's a delicate balance. We don't want to lose too much atmosphere too quickly, but we also need to bring the pressure down over time to a level where humans can walk on the surface without needing pressurized suits. Now, while all of this is happening, there's one more thing we can't ignore: hazards. As we warm up Titan, melting methane lakes and releasing stored gases from the surface, we risk destabilizing parts of the moon. Methane is flammable, so introducing too much heat too quickly could cause explosions or even fires on Titan's surface. This is why the climate engineers we talked about earlier play such a crucial role. They're constantly monitoring temperature fluctuations and methane levels to ensure we don't trigger any dangerous reactions. The goal is to warm Titan just enough, slowly and carefully, so we can avoid any catastrophes. One of the most fascinating aspects of this phase is how interconnected everything is. By removing methane, we warm the planet. By introducing oxygen, we start creating a breathable atmosphere. But each change has ripple effects that need to be managed carefully. It's not just about creating conditions for humans, it's about maintaining balance as we reshape an entire world. What's incredible is that even though this seems like an impossible task, each of these technologies already exists in some form today. We're not talking about theoretical science anymore, we're talking about technologies that have been tested and proven in smaller experiments right here on Earth. And now, in 2150, we're scaling them up for the most ambitious project humanity has ever undertaken. But the real challenge, and the real beauty of this phase, is that everything we're doing isn't just preparing Titan for us. It's setting the stage for something even more incredible: the introduction of life itself. Because once we have an atmosphere that's warm, breathable, and stable, we can begin to introduce the first signs of life. And that's when things really start to get exciting. With the atmosphere starting to take shape, methane levels dropping, oxygen slowly rising and the temperature inching upward, the next critical step is to introduce life. But we're not talking about trees, animals, or humans just yet. We have to start much smaller with microbes. So why microbes? Why not just jump straight to plants or something bigger? Well, the reality is that Titan is still an incredibly hostile place even with the atmosphere modifications we've discussed. To create an ecosystem that can support complex life, we need to start at the foundation. Microbes are the unsung heroes of terraforming. They help condition the environment, transform the soil, and even regulate atmospheric gases in ways that make it more habitable for life forms down the road. The first microbes to arrive on Titan will be specially designed to thrive in conditions that would kill just about anything from Earth. These are not your average bacteria. They're genetically engineered extremophiles, organisms capable of surviving in extreme environments. Scientists have been working with extremophiles for decades, studying life forms that exist in Earth's most extreme places. Think deep-sea hydrothermal vents, acidic hot springs, or Antarctic ice. The microbes we send to Titan are built on the backs of these discoveries, modified to not only survive but to transform Titan's surface. What exactly will these microbes be doing? Their primary job is to help jumpstart a basic carbon cycle and eventually an oxygen cycle. Some of these microbes will be designed to consume methane, breaking it down further and producing byproducts that are less harmful to the atmosphere. Others will start working on the frozen hydrocarbons on Titan's surface, breaking them down and slowly converting them into something more akin to Earth's soil, where future plant life can eventually take root. But there's another kind of microbe that plays a key role here: cyanobacteria. These little guys are photosynthetic, meaning they use sunlight to produce energy, and in the process they release oxygen as a byproduct. Cyanobacteria are actually some of the oldest forms of life on Earth, and billions of years ago, they were responsible for producing much of the oxygen we now breathe. On Titan, their job will be the same: to help convert the atmosphere into something humans can eventually survive in. As they consume carbon dioxide and release oxygen, they'll accelerate the oxygenation of Titan's atmosphere, complementing the artificial photosynthesis systems we've already deployed. This process doesn't happen overnight. It's slow, really slow. We're talking about decades, even centuries of microbial activity before we see significant changes in Titan's environment. But this is where the long-term vision comes into play. The microbes we introduce today are laying the groundwork for the ecosystems of tomorrow. And the beauty of this process is that once it starts, it becomes self-sustaining. The microbes reproduce, spread, and adapt to new niches on the moon, gradually transforming the landscape and the atmosphere. But introducing life to Titan isn't as simple as just scattering a few microbes and waiting for the magic to happen. We need to carefully control and monitor their progress. This is where the biotechnologists and astrobiologists we talked about earlier come back into play. They're constantly collecting data from the surface, tweaking genetic sequences as necessary, and ensuring that the microbial colonies aren't mutating in ways that could throw off the delicate balance we're trying to create. And yes, mutation is something we have to watch closely. In an environment as extreme as Titan, even engineered microbes can evolve in unexpected ways. Some mutations might be beneficial, helping the microbes adapt even more efficiently. Others, however, could be harmful, potentially creating new problems in the atmosphere or the surface chemistry. This is where CRISPR and other gene editing technologies become critical. By constantly refining the microbe's DNA, we can ensure they continue doing their job without destabilizing the environment. What's fascinating is that these microbes will not only change the atmosphere, but they'll also begin to shape Titan's surface in ways that will make it more recognizable to us. Over time, as the microbes break down hydrocarbons and methane, they'll start to create something like soil, a rudimentary form of Earth-like dirt mixed with water ice and minerals from Titan's crust. This proto-soil will be the foundation for plant life, which we'll talk about in the next phase. But right now it's all about preparing the canvas. The microbes are like the first brushstrokes, laying down a layer of life that will eventually give way to more complex organisms. But here's something really interesting. This microbial activity could actually change the color of Titan's surface. Right now, Titan's surface is a dull, orangey brown, thanks to all the hydrocarbons and methane in the atmosphere. As the microbes break down these compounds and release oxygen, we might start to see patches of green or even blue, depending on the types of bacteria and algae that start to take hold. Imagine looking up at Titan from a distance and seeing streaks of color begin to appear, a visual indicator that life is taking root on a once-dead world. And while this is happening, we can't forget the importance of feedback loops. Microbial life doesn't just passively change the environment, it interacts with it. As oxygen levels rise and methane levels drop, it creates a more hospitable environment for the next wave of organisms we'll introduce. Warmer temperatures and a more oxygen-rich atmosphere will speed up microbial growth, which in turn accelerates the entire process of terraforming. It's a delicate balance, but once it starts, the changes will begin to feed into one another, creating a kind of momentum that propels the terraforming process forward. This part of the project is also a critical test. Microbes are our first experiment in introducing life to Titan. If they succeed, they'll pave the way for everything else to come. If they fail, it could set us back decades, forcing us to rethink our entire approach to life on Titan. So as these tiny organisms get to work, the groundwork is laid for the next stage in terraforming. Microbes may seem small and insignificant, but in reality, they're the cornerstone of the entire process. Without them, none of what comes next would be possible. As the microbes quietly transform Titan's atmosphere and surface, the next phase of terraforming is ready to begin, the introduction of plant life. Now this is where things really start to get exciting, because for the first time we're talking about life that we can actually see, plants that will eventually give Titan a whole new identity. But of course we can't just drop a bunch of earth plants onto Titan and expect them to grow. The environment, while vastly improved from its original state, is still far from perfect for traditional life. So the plants we're about to introduce are not your average oak trees or rose bushes. These are genetically engineered superplants, custom built to thrive in the still challenging conditions of Titan. So let's break it down. The first plants to arrive on Titan will be pioneers. Just like the first microbes, they'll be designed to handle cold temperatures, low gravity, and low sunlight. Think of them like the earliest colonists, but instead of building homes, these plants will be building an ecosystem. They'll help stabilize the soil, fix nitrogen into the ground, and release even more oxygen into the atmosphere, accelerating the process that the microbes started. So, what kind of plants are we talking about? One of the leading candidates is a type of genetically modified lichen. On Earth, lichens are incredibly tough organisms that can survive in extreme environments, including the Arctic and even space. For Titan, scientists have created a special version of lichen that can photosynthesize in low-light conditions and withstand freezing temperatures. These lichens are the first step in what's known as biological colonization, the gradual spread of life across Titan's surface. But lichens are just the beginning. After lichens establish a foothold and begin to transform the soil, the next wave of plant life comes in. These are modified grasses and mosses which are incredibly resilient and can spread quickly. Grasses in particular play a crucial role in stabilizing soil and preventing erosion, which is important because Titan's surface, while rocky, is still covered in loose hydrocarbons that need to be bound together. As these grasses and mosses spread, they create a network of roots that hold the soil in place, preventing it from blowing away in the low gravity and allowing other plants to take root. But here's where things get even more interesting. These plants aren't just designed to survive, they're engineered to help terraform Titan faster. Many of them are carbon-fixing plants, meaning they pull carbon dioxide out of the atmosphere and store it in the soil. This has two huge benefits. First, it continues to help clear out Titan's atmosphere, which still contains excess carbon dioxide from the early stages of terraforming. Second, it enriches the soil, making it more hospitable for the next generations of plants. And then, there's the matter of light. Titan receives about 1% of the sunlight that Earth does, which, as you can imagine, isn't exactly ideal for most plants. But this is where the power of genetic engineering really shines, literally. These first plants are designed to be hyper-efficient photosynthesizers. They've been tweaked to make the most of Titan's limited sunlight, using specialized pigments that can capture a wider range of light frequencies than plants on Earth. So even though Titan is much darker than our home planet, these plants can still thrive and grow, slowly spreading across the landscape. Now, as these early plants begin to take root and spread, something magical happens. The color of Titan starts to change. We talked earlier about how microbes might change the surface from its current orange-brown to patches of green. But with plants, the transformation becomes even more dramatic. Imagine looking down at Titan from orbit and seeing vast patches of green, fields of engineered grasses and mosses stretching across the horizon. Over time, these green patches will grow, merging into one another, and Titan will begin to look less like a frozen wasteland and more like a living world. But as always, there are challenges. Titan's low gravity means that plant growth will be very different from what we see on Earth. For example, trees on Earth rely on gravity to pull water up from their roots to their leaves through a process called capillary action. On Titan, where gravity is much weaker, this process doesn't work the same way. So, the plants we're introducing here have been genetically modified to use less water and to circulate it through their bodies in ways that don't rely on gravity. It's one of the many adaptations that make these plants so unique and so crucial to the success of the project. Another challenge is temperature. Even though we're warming Titan, it's still much colder than Earth, and the seasons are much longer with winters that can last for years. The plants we're introducing are designed to go dormant during these long winters, surviving in a kind of hibernation until conditions improve. When the warmth returns, they spring back to life, continuing their slow, steady march across the moon's surface. But beyond these immediate adaptations, these plants also play a deeper, more philosophical role. They represent the first visible signs of life on Titan. For millennia, this moon has been a barren, frozen place. Now, thanks to the introduction of these plants, we're starting to see the first hints of what Titan could become, a world teeming with life. It's a reminder that even in the harshest environments, life finds a way, and with a little help from human ingenuity, it can thrive in places we never thought possible. What's especially exciting is that these plants aren't just about survival. They're part of a long-term vision for Titan, a vision that includes not only self-sustaining ecosystems but also future human colonies. As these plants grow and spread, they're laying the groundwork for something much bigger. They're transforming Titan's surface into something that could one day support forests, crops, and maybe even entire cities. This is just the beginning of a long process, but it's the start of something truly extraordinary. Of course, we're not just planting these organisms and hoping for the best. The entire process is monitored in real time by satellites and drones, which track plant growth, soil conditions, and atmospheric changes. This allows the terraformers to make adjustments as necessary, shifting resources or modifying plant DNA to ensure the best possible results. It's a constant feedback loop. Technology and biology working together to shape the future of a new world. And as this green revolution takes hold on Titan, the next phase of the project begins to loom on the horizon. The introduction of more complex ecosystems, leading to a time when animals, and eventually humans, can walk the surface of Titan without a suit. So, now that we've introduced plant life to Titan, these hardy, genetically engineered pioneers, what's next? Well, the next big leap in the terraforming process is creating a full, self-sustaining ecosystem, and that's no easy feat. Up until now, we've been working with microbes, lichen, and grasses, organisms that are relatively simple and tough. But as we start to shape Titan into a place that could support more complex forms of life, things get a lot more complicated. Let's start with the concept of an ecosystem. On Earth, ecosystems are complex networks of plants, animals, fungi, bacteria, and other organisms, all interacting with one another and their environment. But on Titan, we don't have any of that yet. All we have are isolated pockets of microbial life and patches of grass slowly spreading across the surface. To create a functioning ecosystem, we need to introduce different types of life in a carefully controlled way, starting small and building up. The first step is to bring in more diverse plant species. We've already established grasses and lichen, but now we can start introducing small shrubs, flowering plants, and even trees, specially designed for Titan's conditions. These plants will not only contribute more oxygen to the atmosphere but also help build a richer soil, one that can support a wider variety of life. As these plants grow and spread, they'll create the first true habitats on Titan, places where more complex life forms can survive. But plants alone don't make an ecosystem. We need animals, or at least some form of consumer that can interact with the plants, help spread seeds, break down organic matter, and keep the cycle of life moving. The big question is, what kinds of animals can survive on Titan? Now, introducing Earth animals to Titan straight away isn't feasible, at least not yet. The environment, even with all the changes we've made, is still too hostile. So instead we'll start with something simpler. Insects, and I know what you're thinking. Introducing bugs to a new world might not sound that exciting, but it's actually a huge milestone. Insects are crucial to ecosystems on Earth. They pollinate plants, break down dead material, and form the foundation of the food chain. Without insects, the entire system would collapse. The first insects we'll introduce to Titan will be small and resilient, species like beetles, ants, and pollinators. But just like with the plants, these insects will need to be genetically modified to survive in Titan's unique conditions. We're talking about cold-resistant and low-gravity adapted insects, capable of thriving in an environment that's still vastly different from Earth. Some might even have enhanced senses to help navigate in Titan's dim sunlight. Their job is to interact with the newly established plant life, pollinating flowers, breaking down dead material, and helping to enrich the soil. As the ecosystem on Titan becomes more stable, we'll begin to introduce more complex life forms. And here's where things get really interesting. Scientists are already working on creating genetically engineered animals that can survive on Titan. These animals are based on Earth species, but with modifications to help them handle the cold, the low gravity, and the unique atmospheric conditions. For example, imagine introducing cold-adapted rodents or small herbivores, animals that can graze on the grasses and shrubs that now cover parts of Titan's surface. These animals will play a critical role in maintaining the ecosystem, controlling plant growth, and helping to distribute seeds. Over time, they'll establish themselves as part of the food web, creating the first animal populations on Titan. Of course, introducing animals to a new world comes with a lot of ethical questions. Are we playing God by designing creatures specifically for this new environment? What happens if these animals evolve in unexpected ways, creating unforeseen challenges? And what about the balance of the ecosystem? What happens if one species dominates or throws off the entire food chain? These are questions that scientists and ethicists will be grappling with for decades, if not centuries, as we move forward with this project. But back to the science. The introduction of these animals will happen in stages just like everything else. First, we'll start with smaller herbivores, animals that eat the newly established plant life. Once they've had time to settle in and reproduce, we can introduce small predators to help control the herbivore population. Over time, the food web will become more complex with different species interacting in ways that mimic the ecosystems we see on Earth. And it's not just about survival, it's about creating a world that's truly alive. The sight of animals grazing on Titan's surface, interacting with the plants and the environment, will be one of the most profound moments in the history of humanity's relationship with space. For the first time, we'll have transformed a distant alien moon into a place that's not just habitable but thriving. Now, while all this is happening, we also need to be mindful of the feedback loops we talked about earlier. The introduction of animals will impact the atmosphere, the soil, and the water cycle. Just like on Earth, animals exhale carbon dioxide, which will need to be balanced with the oxygen produced by the plants. And as animals break down organic matter, they'll contribute nutrients to the soil, further enriching it and allowing more complex plant life to grow. It's a delicate balance, and we'll be monitoring it closely to ensure that the ecosystem doesn't spiral out of control. One fascinating aspect of this process is that it's not just about copying Earth's ecosystems and transplanting them to Titan. We're actually creating something entirely new, a hybrid ecosystem where genetically modified Earth organisms interact with the unique environment of Titan. Over time, these ecosystems might evolve in ways we can't even predict, adapting to the specific challenges of living on a moon with low gravity, long seasons, and dim sunlight. But there's something else to consider. As we introduce more complex life forms, we're also getting closer to the point where humans can live on Titan, not just in enclosed habitats but out in the open, breathing the air, walking among the plants and animals we've created. And that, of course, raises a whole new set of questions about how we interact with this newly terraformed world. Will humans be part of this new ecosystem, or will we be its caretakers? How will we balance our needs with the needs of the life we've introduced? And what does it mean to create a world from scratch? One where we decide which species live and which don't. But those are questions for later. Right now, the focus is on building a stable, self-sustaining ecosystem, one that will not only support life but will also continue to evolve over time, just like ecosystems on Earth. This is the moment when Titan starts to transform from a barren moon into a living world, where life in all its forms begins to take hold. As we move deeper into the process of terraforming Titan, one question looms large. What about water? Sure, we've planted grasses, introduced insects, and even started talking about animals, but none of that can happen without a reliable source of liquid water. On Earth, water is the foundation of life. It drives ecosystems, nourishes plants and animals, and shapes the very landscapes we live in. But on Titan, things aren't quite that simple. Titan has water, lots of it in fact. But here's the catch, it's frozen. Most of Titan's water exists as hard ice, locked away beneath the surface or in massive ice fields. The challenge for terraformers isn't about finding water, it's about unlocking it, turning all that frozen water into liquid that can flow in rivers, fill lakes, and support the life we're working so hard to establish. So, how do we melt all that ice? We've already warmed Titan's atmosphere a bit with the greenhouse gases we introduced earlier in the process, but that alone isn't enough. We need to actively heat the planet to melt significant amounts of water. One of the most promising techniques for doing this is through geothermal energy. Beneath Titan's icy crust lies a hot interior, heated by tidal forces from its parent planet, Saturn. By drilling down and tapping into that heat, we can create geothermal wells that pump warm water to the surface, helping to melt the surrounding ice. But geothermal energy alone won't be enough. We'll also need to use solar mirrors, massive structures placed in orbit around Titan that reflect sunlight down onto specific areas. Remember, Titan only gets about 1% of the sunlight Earth does, so these mirrors are designed to concentrate and amplify the sunlight, warming the surface and helping to thaw the ice. Picture it, giant mirrors floating in space, focusing beams of light onto Titan's surface, slowly melting the frozen water and transforming the landscape below. As the ice begins to melt, we'll start to see rivers and lakes forming, though they won't look exactly like what we're used to on Earth. Titan's low gravity means that water behaves differently here. For one, it moves more slowly, and water droplets tend to form larger, more spherical shapes. Rivers on Titan won't have the same rushing currents we associate with Earth, but they will begin to carve their way through the landscape, creating valleys and channels as they flow. The formation of these water bodies marks a turning point in Titan's transformation. With liquid water available, the plants we've introduced will begin to flourish even more, and new habitats will form for future animal life. These rivers and lakes also help to moderate the climate by absorbing heat during the day and releasing it at night, preventing extreme temperature fluctuations and creating a more stable environment for life. But here's where things get tricky. Titan's natural water cycle is, well, different. On Earth, we're used to the idea of water evaporating into the atmosphere, forming clouds and falling back to the surface as rain. But Titan's atmosphere is still evolving, and right now, it can't support a full Earth-like water cycle. In the early stages, water won't evaporate as easily, meaning that many of the lakes and rivers will be relatively stable, without much evaporation or rainfall. Over time, though, as we introduce more oxygen and nitrogen into the atmosphere, Titan's water cycle will start to look more like Earth's, with clouds forming, rain falling, and rivers flowing in a continuous cycle. Now let's talk about lakes for a moment. Titan already has lakes, but they're made of liquid methane and ethane, not water. These methane lakes are one of the most unique features of Titan, but as we terraform the planet and increase its temperature, these methane lakes will gradually evaporate. This is actually a good thing because methane is a powerful greenhouse gas, and getting rid of it will help stabilize the climate. As the methane evaporates, water will take its place, and these once toxic lakes will transform into beautiful freshwater lakes where life can thrive. But the challenge of water on Titan isn't just about getting it to melt, it's also about managing it. With so much frozen water on the surface, we run the risk of flooding. If we melt the ice too quickly, the water could overwhelm the newly formed ecosystems, drowning plants and animals before they have a chance to adapt. So the process needs to be carefully controlled. Terraformers will have to manage the release of water in phases, ensuring that the ecosystems can grow and evolve alongside the changes in the landscape. One fascinating aspect of introducing water to Titan is the potential for subsurface oceans. There's evidence to suggest that deep beneath Titan's surface, there could be massive oceans of liquid water. These oceans are kept warm by the moon's internal heat, and if we can find a way to tap into them, they could provide an enormous source of water for the terraforming project. Drilling down to these oceans would be a massive engineering challenge, but it's not impossible. In fact, it could be the key to making Titan a truly water-rich world, with vast underground reservoirs feeding rivers, lakes, and maybe even seas. But what about icebergs? In some areas, as the ice begins to melt, we might see giant icebergs floating in Titan's lakes and seas, similar to what we see in Earth's polar regions. These icebergs would slowly melt over time, contributing to the planet's water supply. The sight of floating icebergs on Titan's lakes, surrounded by fields of grass and patches of green, would be a surreal reminder of how far we've come in transforming this frozen moon into a living world. Another interesting challenge with water on Titan is the formation of cryovolcanoes. volcanoes that erupt with water and ice instead of lava. As the surface heats up, these cryovolcanoes could become more active, spewing water onto the surface and creating new rivers and lakes. In fact, some scientists believe that cryovolcanoes could play a crucial role in regulating Titan's water supply, acting as natural pumps that bring water from deep underground to the surface. But all of this, rivers, lakes, icebergs, cryovolcanoes, leads to a bigger question. What does the introduction of liquid water mean for life on Titan? Water is the foundation of life as we know it, and with water flowing freely on Titan's surface, we're one step closer to creating a fully habitable world. But the presence of water also brings new challenges. We'll need to monitor the ecosystems closely to ensure that the introduction of water doesn't disrupt the delicate balance we've been building. Too much water too soon could overwhelm the environment, while too little could leave it dry and barren. And then there's the possibility that Titan already harbors life. Not the kind we're familiar with, but microbial life that thrives in its methane lakes or beneath its icy crust. If that's the case, how will the introduction of liquid water affect these organisms? Will they survive, or will they be driven to extinction by the changes we're making to the planet? These are questions we'll need to answer as we move forward with the terraforming process. So, while water is essential to the success of Terraforming Titan, it's also one of the most complex challenges we face. It's not just about melting ice and filling lakes. It's about managing the flow of water, balancing the ecosystems, and ensuring that the introduction of water leads to life, not disaster. Alright, so we've talked about introducing life, water, and ecosystems to Titan, but here's the next big question. How do we make Titan's atmosphere breathable for humans? At this point in the terraforming process, we've made some major progress. The air is warmer, we've got rivers and lakes forming, plants are thriving, and maybe even some insects and small animals are starting to call Titan home. But for humans to live and walk on the surface of Titan without the need for heavy spacesuits or pressurized domes, we need to turn its alien atmosphere into something we can actually breathe. Let's break down the problem. Right now, Titan's atmosphere is mostly nitrogen, which is actually good news. Nitrogen makes up about 78% of Earth's atmosphere, so in that sense, Titan already has a lot going for it. The bad news? The rest of Titan's atmosphere is mostly methane and hydrogen, both of which are toxic to us. On top of that, there's almost no oxygen, which of course we need to survive. So, how do we fix that? The goal is to create an atmosphere that mimics Earth's roughly 21% oxygen, 78% nitrogen, and the rest made up of small amounts of other gases like carbon dioxide and argon. But how do we go from Titan's current methane-heavy atmosphere to something that's breathable? The process of transforming an atmosphere on this scale is a monumental challenge, but it's not impossible. In fact, we've already taken some crucial steps earlier in the terraforming process. Remember those genetically modified plants we introduced? They've been working hard, converting carbon dioxide into oxygen through photosynthesis. Over time, these plants will start pumping more and more oxygen into the atmosphere, slowly shifting the balance away from methane and carbon dioxide. But plants alone aren't enough. We need to actively scrub the methane and hydrogen out of the atmosphere. This is where advanced atmospheric processors come into play. Atmospheric processors are massive machines designed to pull in Titan's air, strip out the harmful gases like methane, and release oxygen and nitrogen back into the atmosphere. Think of them like giant air purifiers, but on a planetary scale. These machines would work around the clock, slowly converting Titan's toxic atmosphere into something humans can breathe. Over time, we'd start to see methane levels drop, replaced by a growing concentration of oxygen. But here's the thing, simply removing methane isn't enough. We also need to stabilize Titan's atmosphere to prevent it from losing its gases to space. You see, Titan's gravity is weaker than Earth's, which means it's easier for light gases like oxygen to escape into space. To combat this, we'd have to thicken the atmosphere by adding heavier gases that can trap oxygen and prevent it from drifting away. One solution is to introduce more nitrogen and argon, which are both relatively heavy and can help anchor the atmosphere in place. And, while we're talking about stabilizing the atmosphere, we can't forget about the magnetosphere. Earth is protected by a magnetic field that shields us from harmful solar radiation and cosmic rays, but Titan doesn't have this natural defense. So, part of terraforming Titan involves creating an artificial magnetosphere to protect the planet's atmosphere and its future inhabitants from radiation. How do we do that? Well, there are a few ideas on the table. One involves building giant magnetic field generators at strategic points around Titan's equator, creating a protective shield similar to Earth's. Now, let's talk about weather. As we adjust Titan's atmosphere, we're also going to see changes in its weather patterns. Right now, Titan experiences something that might seem familiar to people living near the poles on Earth: methane rain. But as we scrub methane from the atmosphere and introduce more oxygen, the planet's weather will begin to shift. Instead of methane storms, we might start to see water-based weather, clouds forming, rain falling, and even snow in some areas. One of the most fascinating aspects of terraforming Titan's atmosphere is how it will transform the planet's seasons. Titan already has seasons thanks to its tilted axis and orbit around Saturn, but these seasons are long, each one lasting about 7 Earth years. As the atmosphere thickens and warms, these seasons will become more pronounced, with changes in temperature, rainfall, and even the length of day and night. Imagine living on Titan and experiencing seasons that last for years, where summer days stretch on for months and winter brings long, cold nights. But even as we work to make Titan's atmosphere breathable, there's another question lurking in the background. Should we do it? The ethical implications of transforming an entire planet's atmosphere are huge. On one hand, creating a breathable atmosphere would allow humans to live and thrive on Titan without the need for enclosed habitats. On the other hand, are we erasing something unique about Titan by making it more Earth-like? Once we've transformed the atmosphere, there's no going back. The moon will no longer be the alien world it once was, but instead a hybrid, a new version of Earth with its own distinct identity. And then there's the issue of time. This process isn't going to happen overnight. In fact, we're talking about a timeline that spans centuries, if not millennia. The atmospheric processors will be working for generations to come, slowly but surely shifting the balance of gases in Titan's favor. Future generations will grow up watching the sky change, breathing air that becomes more and more like Earth's with each passing decade. As oxygen levels rise, humans will begin spending more time outdoors, first with specialized breathing masks and eventually without any equipment. The first unassisted breath of Titan's air will be a monumental moment, marking the transformation of this once alien world into a livable place. However, many challenges remain. Titan's atmosphere is still extremely cold, so we must continue warming it, possibly by expanding our solar mirror network or releasing more greenhouse gases. It's a delicate balance. We need to warm the planet enough to support life without triggering runaway warming or rapidly melting polar ice caps, which could cause massive floods. Another challenge is creating the right pressure. Titan's surface pressure is actually higher than Earth's, which means we'll need to reduce the pressure over time to make it comfortable for human life. This could be done through a combination of atmospheric thinning and temperature control, but it's a long and complex process. And finally, there's the question of oxygen toxicity. Too much oxygen in the atmosphere can actually be dangerous for humans, leading to a range of health problems. We'll need to carefully monitor and control the oxygen levels as we terraform Titan, ensuring that they stay within a range that's safe for human life. But despite all these challenges, the vision of a fully terraformed Titan, a world with blue skies, flowing rivers, thriving ecosystems, and a breathable atmosphere, is within reach. It's a vision that's not just about survival, but about creating a new home for humanity, one where we can live and thrive alongside the life we've introduced to this distant moon. Now that we've made significant progress in transforming Titan's atmosphere, let's talk about one of the most crucial aspects of terraforming: creating sustainable habitats for humans. We're not just looking to drop a few domes on the surface and call it a day. No, we need to create environments that are not only livable but can also thrive independently over time. First off, let's think about the structure of these habitats. Titan's environment is unique. The surface is incredibly cold, averaging around -290 degrees Fahrenheit or -179 degrees Celsius, so we need to consider insulation and temperature control. To achieve this, we might build habitats using multi-layered materials. Think of a thermal blanket that traps heat but is also strong enough to withstand Titan's atmospheric pressure. One innovative idea is to use inflatable habitats. These structures can be deployed in layers, allowing for an easy setup that can expand over time. The outer layer would serve as a protective barrier against the harsh environment, while the inner layers could be filled with air to maintain a comfortable living space. This design minimizes the amount of material needed, and can adapt as our colony grows. As we set up these habitats, we'll also need to consider the resources we'll require. Right now, Titan has abundant resources, but transporting everything we need from Earth isn't practical. That's where local resource utilization comes into play. We'll need to harness Titan's natural resources to create a self-sustaining ecosystem. For instance, we could use the ice found on Titan to create water and produce oxygen through electrolysis. By splitting water into hydrogen and oxygen, we could generate breathable air while also finding uses for the hydrogen, like as a fuel source. And then there's the need for food. Growing food on Titan is a challenge, but it's far from impossible. With our earlier efforts to introduce genetically modified plants, we could set up large-scale greenhouses that utilize Titan's sunlight, even though it's dim. These greenhouses would have specialized LED lighting to supplement the limited sunlight and maintain a suitable growing environment. Over time, these crops could become a staple food source for the growing human population. Now let's talk about waste management. In any closed-loop system, managing waste is crucial for sustainability. One approach is to create bioreactors, systems that can break down organic waste and turn it into useful resources. Think of it as nature's recycling system. These reactors could convert waste into compost for our crops or even into energy to power our habitats. But the design of these habitats isn't just about function, it's also about community. As humans begin to live and work together on Titan, we'll need to create spaces that foster connection and collaboration. Imagine neighborhoods designed around communal gardens, recreational areas, and spaces for social gatherings. By prioritizing communal living, we'll build a strong sense of community that will be vital for the long-term success of our colony. Safety will also be a top priority in our habitat design. We have to consider Titan's unique environmental challenges, including potential weather events or changes in atmospheric pressure. This might mean building habitats that are modular and can withstand extreme conditions. For instance, if a storm is brewing, habitats could be designed to seal tightly against the elements, ensuring the safety of their inhabitants. And let's not forget about energy. While we'll harness local resources, we'll also need to set up renewable energy sources to power our habitats. Titan receives very little sunlight, but we can use other methods like nuclear reactors or geothermal energy. Geothermal energy, in particular, could be tapped from Titan's internal heat, providing a steady and reliable power source. Speaking of power, we might also consider the possibility of building solar farms on the surface. These farms would use advanced photovoltaic technology to capture whatever sunlight Titan receives. While it's not as efficient as solar power on Earth, every bit of energy contributes to the sustainability of our habitats. Now, as we build these habitats, we also need to think about transportation. How will people move around? We could develop a network of self-driving vehicles that operate on Titan's surface, providing easy access to different areas and facilities. Or, given Titan's unique landscape, we might design hovercraft that glide over the surface, utilizing Titan's lower gravity to their advantage. One exciting prospect of terraforming Titan is the opportunity for innovation. As we establish these habitats, we can experiment with new technologies and ideas. This can lead to breakthroughs not only for Titan, but also for Earth. Imagine the developments we could make in renewable energy, sustainable agriculture, and habitat design. Ideas that could inspire solutions back home. Ultimately, our goal is to create habitats on Titan that are not just temporary, but are designed to last for generations. They should be flexible enough to adapt to the changing needs of the community, while also being robust enough to handle the challenges of Titan's environment. This vision for sustainable living will be key to our success on Titan and could serve as a model for future colonization efforts on other celestial bodies. As we move forward, we'll need to continuously assess and improve our habitats. This might involve ongoing research, technological advancements, and community feedback. The journey of terraforming Titan isn't just about survival, it's about thriving and finding harmony in this new world. Now that we've laid the groundwork for sustainable habitats and infrastructure on Titan, it's time to turn our attention to something equally important: creating a new society. Terraforming Titan isn't just about transforming the environment, it's about shaping a culture, building communities, and establishing a way of life that reflects our values and aspirations. So how do we do this? First off, let's consider the people who will inhabit Titan. Initially, we might send small teams of scientists, engineers, and support staff to kickstart the terraforming efforts. But as the environment becomes more hospitable, we'll need to think about how to attract a broader population. What kind of people will want to leave Earth for Titan? Perhaps it'll be adventurous souls seeking new frontiers, families looking for opportunities, or even individuals drawn by the chance to help build a new world from the ground up. Creating a sense of belonging and community will be essential. From the very beginning, we'll need to prioritize inclusive practices. Think about how we can involve diverse voices in the decision-making process, ensuring that everyone feels heard and valued. This approach will help foster a society that's built on collaboration, respect, and shared goals. Education will also play a vital role in shaping Titan's society. As new generations are born on Titan, we'll need to create educational systems that prepare them for life in this unique environment. Imagine schools that focus not just on traditional subjects, but also on subjects like planetary science, environmental stewardship, and sustainable living. Kids growing up on Titan will need a strong understanding of their world, as well as the skills to innovate and adapt. As we think about society, we can't overlook the importance of governance. What type of political system will emerge on Titan? Should it mirror Earth systems, or do we have the opportunity to create something new? There's potential for a more decentralized form of governance where communities have greater autonomy and decision-making power. This might help to foster innovation and allow for tailored solutions that meet the specific needs of different habitats. A thriving society also needs a rich cultural life. As we build our new homes, we should encourage the arts, music, and creativity. Imagine community centers where people gather to share their experiences, host performances, and celebrate their unique cultural heritage. These gatherings will not only enrich our lives but also help us form bonds that strengthen our community. And let's not forget about the role of technology in shaping Titan's society. We're talking about a world where communication technology can bridge distances in ways we've only begun to explore. Instant messaging, virtual reality, and immersive experiences could keep people connected across habitats, fostering a sense of unity among Titan's inhabitants, even if they're physically distant. Another fascinating aspect of life on Titan will be the relationship with the environment. Living on a terraformed moon presents unique challenges and opportunities. We'll need to instill a culture of environmental responsibility, teaching future generations to respect and protect their new world. This includes understanding the balance of ecosystems we've created and finding ways to enhance biodiversity. Let's also consider the role of tradition. As humans adapt to life on Titan, we might develop new customs and practices that reflect our unique experiences. Celebrating milestones like the first successful harvest of Titan-grown crops or the anniversary of our terraforming efforts could foster a sense of history and identity. These traditions will help define what it means to be a Titanian. Yet, with all the excitement of creating a new society, we must be mindful of the challenges that will arise. As we introduce new technologies and systems, conflicts may emerge. There might be disagreements over resource allocation, differences in cultural perspectives, or tensions between habitats. It will be essential to have conflict resolution mechanisms in place, perhaps even community forums where individuals can come together to discuss issues openly and collaboratively. As our society grows, we'll also need to confront ethical questions. What does it mean to be human on Titan? As we begin to see changes in our biology, perhaps due to living in a different atmosphere or under different gravity, we might need to explore what identity means in this new context. How do we balance our Earth heritage with our new life on Titan? One potential aspect of this new society could be the development of a Titanian identity. This identity could be shaped by our unique experiences, the challenges we've overcome, and the relationships we've built with each other and the environment. As we evolve, we may find that we develop a new sense of belonging that transcends our earthly origins. And while we're dreaming big, let's think about how we can maintain connections with Earth. How can we share our experiences, challenges, and successes with those back home? Establishing a two-way communication system will be vital. Perhaps we can even create an annual event where Titan inhabitants share their progress and experiences with Earth, an interplanetary cultural exchange. Finally, it's crucial that we encourage a mindset of exploration and innovation. Living on Titan gives us a unique opportunity to experiment and push the boundaries of what we know. As we face new challenges, we'll need to foster a culture that embraces creativity, resilience, and the willingness to take risks. Building a new society on Titan isn't just about survival, it's about thriving together as we create a vibrant, inclusive, and innovative community. We have a chance to shape our destiny and redefine what it means to live on a new world. And as we continue this journey, we'll face both challenges and triumphs, each contributing to the rich tapestry of life on Titan. Now that we've discussed creating a thriving society on Titan, let's dive into another crucial aspect of our new home: scientific research and exploration. Titan isn't just a new place to live, it's a treasure trove of mysteries waiting to be unraveled. As we transform this moon, we'll also have the unique opportunity to conduct groundbreaking research that could change our understanding of science, biology, and the universe. First, let's consider Titan's unique environment. It's the only place in the solar system, aside from Earth, known to have stable bodies of liquid on its surface, methane and ethane lakes. Imagine the scientific potential here. These lakes could hold clues about the origins of life. Studying the chemical processes happening in these hydrocarbon lakes might help us understand how life could emerge in environments very different from our own. We could even look for extremophiles, organisms that thrive in extreme conditions, similar to those found in Earth's deepest oceans or harshest deserts. Remember how we talked about transforming it into a more Earth-like composition? As we do this, we'll have the chance to conduct detailed studies on its atmospheric chemistry. By deploying aerial drones and balloons, we can sample the atmosphere at different altitudes and gather data about the composition, weather patterns, and even climate change over time. This research could provide valuable insights into planetary atmospheres, benefiting our understanding of not just Titan, but also other celestial bodies like exoplanets. For instance, the methods we develop for resource utilization on Titan, like extracting water from ice or converting methane into usable fuel, could have real-world applications back home. Imagine adapting these technologies to address water scarcity or energy production challenges on Earth. Another fascinating aspect of Titan is its potential for astrobiological research. With its thick atmosphere, diverse organic compounds, and stable environments, Titan serves as a natural laboratory for studying the conditions under which life might arise. We could set up research stations dedicated to studying extremophiles and testing the limits of biological adaptation. What if we find life forms that have evolved in ways we never expected? This could reshape our understanding of life in the universe and offer clues about the potential for life elsewhere in the solar system. As we conduct this research, we should also consider the development of international collaboration. Just as we share our knowledge and experiences back to Earth, we can invite scientists and researchers from around the globe to join us on Titan. This could lead to a rich tapestry of perspectives, driving innovation and creativity in our research endeavors. Imagine a multinational team working together to solve complex problems, sharing their expertise and learning from each other's experiences. We're likely to see advancements in robotics and artificial intelligence, with machines that can perform tasks in extreme environments. For example, we could deploy rovers equipped with advanced sensors to explore the surface and gather data about Titan's geology. These rovers could analyze soil samples, identify organic compounds, and even map out the best locations for future habitats. Speaking of technology, let's not forget about the importance of data collection. As we gather information, we need to think about how we'll store and analyze this data. We might set up an extensive cloud-based system that allows researchers to access real-time information, share findings, and collaborate on projects. Moreover, we can expect that scientific exploration on Titan will lead to unexpected discoveries. We might stumble upon geological formations or phenomena that challenge our existing theories. For instance, imagine uncovering evidence of past geological activity, or even ancient lakes that might have existed millions of years ago. Each finding would provide more context about Titan's history and how it has changed over time. In addition to studying Titan's geology and atmosphere, we should also consider the potential for ocean exploration beneath its icy crust. Titan is believed to have a subsurface ocean of water mixed with ammonia. This hidden ocean could be a goldmine for research. It might harbor life forms or reveal insights about planetary formation and evolution. Developing technology capable of penetrating the thick ice and exploring these oceanic depths could open up entirely new avenues of scientific inquiry. Let's also remember the role of public engagement in our research efforts. Sharing our findings with the world will not only build excitement about the mission but also inspire future generations of scientists and explorers. We could establish programs that allow students from Earth to participate in experiments, design their own research projects, or even communicate with Titan researchers through video calls. This kind of engagement fosters a connection between Earth and our new colony, encouraging young minds to dream big and consider careers in science and exploration. Finally, as we conduct our research, we need to remain committed to ethical considerations. This means being mindful of how our actions might impact Titan's environment. As we explore, we should establish guidelines to protect its unique ecosystems and ensure that our scientific activities do not disrupt the delicate balance we're working to create. This commitment will reflect our values and help us develop a sustainable approach to exploration. Scientific research and exploration on Titan will be a driving force behind our mission to terraform and inhabit this moon. From studying its unique environment to developing innovative technologies, we have the chance to expand our knowledge and redefine our understanding of life in the universe. Each discovery will not only enrich our lives on Titan, but will also provide valuable lessons for humanity as a whole. While the vision of a thriving, human-friendly Titan is exciting, we can't overlook the significant challenges that come with terraforming such a unique and distant world. In this part, we'll explore some of the hurdles we'll face and how we can tackle them head-on. First and foremost, let's talk about the environmental conditions on Titan. With surface temperatures hovering around -290 degrees Fahrenheit, the extreme cold presents a massive challenge. It's not just about keeping our habitats warm, we need to ensure that all our equipment, vehicles, and systems can withstand these frigid temperatures. This means we'll need to invest in advanced materials and technologies designed for cryogenic conditions. For example, developing thermal insulation that can keep habitats warm while resisting Titan's icy elements will be crucial. Next, there's the issue of transportation. Titan's vast landscape includes thick layers of ice, hydrocarbon lakes, and rugged terrain. Getting people and supplies from one habitat to another will require innovative transportation solutions. We might consider building a network of hovercraft that can glide over the surface or even submersible vehicles for navigating the methane lakes. Additionally, establishing efficient supply routes will be essential to ensure that all habitats remain well stocked with necessary resources. Then, let's think about energy. While Titan has abundant hydrocarbons that could potentially be converted into fuel, harnessing and converting this energy efficiently poses another challenge. We'll need to develop robust energy systems that can handle the demands of our growing population while being sustainable and environmentally friendly. This could involve a combination of solar, nuclear, and geothermal energy sources, each with its own set of challenges to overcome. Another significant concern is resource management. As our colony grows, so will our demand for essential resources like water, food, and building materials. We'll need to implement sustainable practices that prioritize recycling and resource utilization. This means investing in advanced technologies that allow us to recycle waste and convert it back into usable materials. For instance, creating closed-loop systems for water and nutrients will help reduce our reliance on transporting resources from Earth. As we expand our presence on Titan, we must also be prepared for potential natural disasters. Titan's atmosphere can produce storms and high winds, which may pose risks to our habitats. Establishing resilient building designs and emergency response plans will be vital. We'll need to regularly monitor weather patterns and develop early warning systems to keep everyone informed of potential threats. Let's not forget about psychological challenges. Living on Titan, far from Earth, will present unique mental health challenges for our settlers. The isolation, confinement, and extreme environment can lead to feelings of loneliness or anxiety. To address this, we'll need to implement comprehensive support systems, including access to mental health resources and opportunities for social interaction. As we embark on this terraforming journey, we should also be mindful of ethical considerations. The act of terraforming an entire moon raises questions about our responsibilities as stewards of this new environment. How do we ensure that we respect any potential life forms that may exist? How do we balance our desire for exploration with the need to protect Titan's unique ecosystems? And finally, we can't ignore the potential for political challenges. As we establish a presence on Titan, questions about governance and ownership will inevitably arise. Who will make decisions for the colony? How will we ensure that all voices are heard? Developing a fair and just governance system will be key to maintaining social harmony and cooperation among settlers. What does our presence on this distant moon mean for our species? How will our experiences on Titan shape our evolution, both socially and technologically? First, let's consider how life on Titan will change us. Living in such a unique environment will push us to adapt in ways we can't fully anticipate yet. From physiological changes due to lower gravity and different atmospheric conditions to the development of new cultural practices born from the challenges of colonization, Titan could very well become a crucible for human evolution. This evolution might not just be physical. Our societal structures, values, and even our understanding of community could shift dramatically. Imagine a society where collaboration is essential for survival. On Titan, the reliance on one another will be more critical than ever. This could foster a stronger sense of community and collective responsibility, shaping a new human identity that values cooperation over competition. The lessons we learn from our experiences on Titan could lead to more peaceful interactions back on Earth, as we embrace a mindset of global unity and cooperation. Now let's think about the technological advancements that will emerge from our efforts on Titan. The challenges we face, developing new energy systems, sustainable agriculture techniques, and advanced communication tools, will likely result in breakthroughs that benefit not just Titan, but also Earth. Innovations in resource management and recycling technologies, for example, could have profound implications for how we address environmental issues on our home planet. We can also expect that our time on Titan will fuel scientific curiosity. The desire to explore and understand our universe is an inherent part of being human. Titan could serve as a stepping stone for future explorations of the outer solar system, like the moons of Jupiter or even Mars. Each discovery on Titan could inspire missions to new worlds, expanding our reach and understanding of the cosmos. Picture a future where humans are seen as interplanetary explorers, venturing into the unknown and uncovering the mysteries of the universe. Moreover, the experiences we gain on Titan could inform our approaches to planetary colonization elsewhere. By developing best practices in terraforming and resource utilization, we'll create a framework for future endeavors, perhaps even the colonization of exoplanets in distant star systems. As technology progresses, the dream of reaching worlds beyond our solar system may one day become a reality. Imagine humans on a distant exoplanet, applying the lessons learned from Titan to create sustainable habitats on a new world. Of course, this journey won't be without its ethical implications. As we venture into the cosmos, we'll need to grapple with questions about our responsibilities as stewards of other worlds. What rights do we have to alter an ecosystem, even one as inhospitable as Titan's? How can we ensure that our actions don't lead to unforeseen consequences? These questions will require thoughtful dialogue and ethical considerations, shaping our policies and approaches to space exploration. Now let's turn our gaze back to Earth. The impact of our endeavors on Titan won't just be felt in the outer solar system. It could also resonate profoundly here at home. As we develop new technologies and sustainable practices on Titan, we may find solutions to the pressing challenges facing humanity, such as climate change, resource scarcity, and population growth. The innovations we create could serve as a blueprint for creating a more sustainable and equitable world on Earth. And as we share our successes and failures with the people of Earth, we'll foster a sense of shared destiny. The achievements on Titan will become a source of inspiration for future generations, motivating them to dream big and pursue their passions in science, technology, and exploration. By connecting our efforts on Titan with those back home, we create a narrative of hope, possibility, and collaboration.